Recording. Alright, hello everyone. Apologies, had to do some quick OBS updating for those of you who are watching asynchronously. So we were, when we last left off, about to apply some force to our ball, particularly when we hit the spacebar in our game. And we want to make sure that we are putting this in our update function. This update function is called once per frame. So every frame, the game will be checking if the spacebar gets pressed. If it does, we want to apply upward velocity to our ball. Seems reasonable. We can also modify this by giving it, let's say, extra force. So this, by default, this is vector 3 up is 0, 1, 0. Right? It is the vector representation of the unit vector. We can also give it some extra oomph, let's say, by declaring a private float called force. And we are going to initialize it to, let's say, 5F. Whenever you are doing floats within Unity, make sure that you append your numbers with F. That will let the system know that you are using a floating point number. We also want to make sure that this gets multiplied by our force. All right, let's see how that works. Let's go back to Unity and make sure that I shift my windows here. All right, let me make sure that that actually worked. You should be seeing Unity. Excellent, great. All right, let's hit the play button. And let's hit the spacebar. Let's see what happens. Ah, there we go. Got a little jump. Every time I hit the spacebar, our ball goes up just a little bit. How about if we changed our force? We can do that while we're in play. Let's change it to 10 and see what happens. It goes up a little further. Excellent. All right, so you'll note, however, any changes that we make in play mode do not get saved when we return to our editor. So refrain from making changes that you will want to save in play mode, and make sure that you are doing this in the editor. Or figure out what works in play mode so that you don't have to keep starting and stopping, and then make sure that you remember what value you want. So we now have a ball that can be launched on spacebar press upward. That's excellent. Okay, great. Now what do we want next? We want some sort of, let's say, a blocker, right? We want some sort of barrier. So let us do that. And in fact, I think what I'm going to do is cheat a little bit. And I am going to select the ground, let's say, and using the keyboard command Control-D, if you're on Windows, if it's, I think on Mac, you might be Command-D, Control-D on Windows, we can duplicate this game object, ground. Let me make sure everything is good on Discord. Good, excellent. So we duplicated ground. Let's make it into a barrier of some sort. First, let's position it maybe at y equals 1. Let us call this blocker. Let's shrink it a little bit. Maybe we'll make it 1 by 1. How does that look? Oh, I can't quite see it in my game view, so maybe what I'll do, instead of having our skybox, I think what I'm going to do is go to our camera, our camera component and select solid color. So that way, when I go back to our game view, it's not the skybox, it's just this blue background. Cool. All right, and I can see this blocker got added. Excellent. And when I click play, and everything compiles, and I hit space. There we go. Yeah, we're being blocked, which is the goal. So that's good. All right. Now we want to introduce some interesting behavior for our blocker, right? We want to, let's say, have it move back and forth. That would be interesting, right? So let's see. How can we do this? I think the most reasonable way of doing this would be to create another kind of cube. And I'm going to zero it out, as we always do. And I am going to put this cube, actually I'm going to name it. I'm going to name it right bumper. Right bumper, cool. All right, and I'm going to place it at x equals 1 and x equals minus 5. How about that? Minus 5. X equals minus 5. And then I am going to flatten it out a little bit. Flatten it on its x here. We want it to be thin that way. In fact, I might bring this back to the center a little bit, maybe minus 4. And then I want to heighten it just a bit. We can do that by scaling its y. Okay. And then I'm going to duplicate using Control D once more, and I'm going to create a duplicate of the right bumper. But this time, I'm going to place this one at positive 4. And now we have two bumpers. This one I'm going to rename left bumper. Okay, so now when we look at our game, we have some bumpers on either side. When the vision is that our blocker moves left to right, hits these bumpers, and switches direction, so it continually goes over our platform. Okay, we can leave in our the physical representations of these elongated cubes now, or we can simply remove them. And I think that's what I'm going to do, just so that they are colliders. I'm going to right-click on Cube Mesh Filter. I'm going to right-click that and select Remove Component. And then again, for Mesh Render, removing that, just so that we have Box Collider left. Now, I want our blocker to move from right to left and look like it is hitting something, change direction, and do the same for each bumper. We are going to need to assign a script to the blocker in order to do that. So let's do that. We can right-click in our project area, create a new C# script. I'm going to name the C# script blocker. And then I'm going to drag blocker once everything is compiled. Drag blocker onto our blocker game object in our hierarchy. And now we should be able to see blocker has been added, our C# script blocker. So let's open that up in Visual Studio, and I'm going to make sure I switch scenes. Excellent. Check, make sure that's working. Great. Great, okay. So I've just opened up blocker. Now what do I want blocker to do? As we said, we want to move from left to right. Well, there's a very, very easy way for us to do that. And that way is by accessing this game object's transform. And we can very easily do that by just typing transform. But we want its position. We want to access its position. So its space, its location in space. And we want to, let's say, add vector3 dot right. Similar to how we were modifying the unit vector of our ball's velocity, we are going to do the same for our blocker here. And we are going to give this blocker, let's say, a speed, private float speed, and we'll do it at 5f again. Excuse me. Here we go. And I want to multiply by its speed. Cool. All right, let's try this out. Let's go back to Unity. Shift screens, have everything compile. Excellent. Cool. All right, let's hit play. Whoa. It's moving so fast, we didn't even really get to see it. You can see we have our blocker game object selected, and its position is rapidly changing. The reason it's rapidly changing is that this move function is located in our update. Update gets called every time it can, every frame update. Currently, this is running at 30 FPS because I'm streaming and recording, but this is running every frame update. So what do we have to do? We have to normalize this somehow. And the way that we do that is by multiplying by a special value. And this is time.delta time. This is the time between the last frame. So in effect, by multiplying our value with time.delta time, we are normalizing its movement. All right, so let's try that. Let's go back to Unity. And let's hit play. And see what happens now. There we go. It's a little jagged because it's a little laggy, but it's looking better, right? It's normalized to a much more decent rate. Okay, so we have it moving right. Now we want to actually have it change direction once it hits our bumpers. So how can we do that? We can take a look at our bumpers. We can make these bumpers into triggers that our blocker will interact with. And the way that we do that is by making sure that our colliders are set to triggers. So right bumper and left bumper both are going to be triggers. And then for both our right and left bumper, we're going to add a rigid body component. But we don't really want these bumpers to have physics act on them. We just want them to be there in order to be triggered. So the way that we do that is by selecting is kinematic. And this controls, if we hover over this, you can see it. It says controls whether physics affects the rigid body. So if we select that, for both of our bumpers, and then we're not done yet because we haven't really written the code that will switch the direction of our blocker, right? So we need to go back to our code and make sure that we are trying to detect when this thing enters a trigger. So on trigger enter. collider other. These are special functions that are defined within Unity. So if you have a function that is called on trigger enter, it will expect that the argument type is a collider, and the collider that is being referenced is whatever this particular game object, the game object that this script is attached to, whatever it is touching. That's why I have called this collider other. On trigger enter, if the blocker touches any other collider, really what we want to do is flip our speed, right? That's really all we want to do. If we flip our speed and make it negative, then we'll be changing direction, right? Because this is a vector. So if we set speed was equal to minus speed, we should be in business. Let's see. Let's go back to Unity. And let's hit play. Ah, there we go. We can see we have a blocker that is moving right to left, bouncing against our invisible bumpers, and it is behaving the way we would expect it to. And we can see the speed being changed, 5 to -5, back to 5, and so on, right? So we've accomplished, we have a ball, we have a blocker, we can hit space, launch our ball, try to get it past the blocker. Okay, that's pretty cool. We have some other things that we can add, and I am going to try to do this quickly. Our little OBS problem kind of shortened our time together, but we are going to try and get a working score going. So let's do that. So we are going to try and create another kind of invisible collider. The same way that we did our bumpers, I am going to duplicate our ground using the keyboard command Control-D again. I'm going to set this at y is equal to 2, so that it is above our blocker. And we're going to call this game object score zone. And our score zone is not going to have a physical representation. So we're going to right-click the mesh and the mesh renderer and remove them. And once again, we are going to make this particular collider a kinemagic. It is kind of kinemagic. We're going to make it a kinematic rigid body, and we're going to set it to be a trigger. So this is going to be our score zone collider. When the ball touches this score zone, we want to increment our score. Okay, so that's cool. How do we set that up? Well, we can do that by creating a new empty game object, and we're going to call this score manager. And as you might guess, we're going to create a new script also by right-clicking. Excuse me, something popped up. We're going to right-click in our project hierarchy, create C# script. We're going to call this score manager. It's going to compile. To take a look at the chat. Let's see. Thank you. Thank you, Chang. All right. Excellent. All right. So we're going to drag our score manager script to our game object. Score manager should now have our score manager script. Let's open it up in Visual Studio and switch to it. Here we are, score manager. We want this score manager to have a variable called score. So let's do that. We are going to do something different with this. We are first going to make it a private variable. And we're going to make it an int. And we're going to set it to 0. And then I'm going to make some public getters and setters for this, so it becomes a property. So public int score. Get return score, set score is equal to value. Cool. All right. So when something wants to, let's say, as our ball, if it touches the score zone, we want to increment the score here, it can access this public property score. And the score manager will keep score. So let us write the actual function that will increment the score. And we want to attach this somehow to a UI element, right? Let's do that first, actually. So let's go back to Unity. Make sure that we switched. Excellent. All right. We are going to create a UI element now. We want it to just read score, maybe in the top left corner of the screen. So let us right-click inside of our project hierarchy, or sorry, our scene hierarchy. We're going to select UI, and then I'm going to select Text Mesh Pro. And we're going to have to import a bunch of stuff. Text Mesh Pro is a third-party thing, but it's slowly being integrated into Unity. There we go. So we have a new text element. A bunch of things just got added to our hierarchy, actually. We have an object called canvas. And this is the thing on which our UI is drawn. It is basically a curtain across which, a 2D curtain, behind which our game is played. So if we double-click on this canvas game object, you can see it's a massive object. And it lives in space as well. Let us then go to our text object here. Let's do a little flipping around here. We can read it. When we look at our canvas, let's zoom in a little bit. We can flatten it out so that we can take a better look at it. This is what will be drawn on the screen. And I am going to, let's just say, write in this text field here, score. Excellent. Now we want to position this UI element. Oh, and I'm going to rename this, actually, to score text. This particular game object is going to be score text. It has a component called Text Mesh Pro Text. That Text Mesh Pro Text component has something called text, and that's our score 0. We can position this by clicking on its rect transform. This is different from it's a game object's normal transform. Every UI element that is meant to be drawn on a 2D plane gets a rect transform, and we can shift its position and its pivot by using these keyboard commands that are listed here. Using Shift and Alt. Shift will set its pivot, and Alt will set its position. If we hit both of these, our score now appears in the top left corner of our screen. And this is great. This is great. We always want this score to appear in the top left corner of the screen, no matter what screen size you might have. Now, we might want to say, give this text some padding. So let's do that. It's touching the absolute edge of the left side and the top a bit. So maybe we want to add some padding. We can set it off to the right a little bit by 10 pixels, and we can set it off from the top by another 10, let's say. So minus 10 and 10. And we give it some nice padding there, so it lives in the upper left corner of the screen. Okay, so we have this game object, we have a UI. When we go to our game view, hey, look, there it is, top left corner of the screen, score 0. All right, now the last thing that we have to do, and this will be the last thing that we do, I'm running out of time, I'm a little over, but I'll finish this. so that we have a somewhat of a game. Let's go to our script and make sure that when our ball touches our score zone, that actual number goes up, and goes up correctly. All right, so let's do that. Let's go to our code. Let me shift Windows. Let's go to our ball script. And our ball is going to have a on trigger enter function. So collider other. So if it collides with a collider that is attached to a game object that has the name score zone. So if it touches the collider that is attached to our score zone game object, what do we want to do? We want to access score manager .score and increment it, right? Okay, how do we do that? If we simply type score manager here, .score, you can see it's not very happy with that, right? So we're going to need to grab some sort of reference to our score manager. And the way that we can do that is by we can serialize this private. We want a score manager, right? That's the class that we created, and I'll abbreviate it SM. On start, SM should be equal to a game object. The reason that I'm doing this by setting it in start, you can imagine a world in which our ball, right, on launch, touches our blocker, it gets pushed off our platform, and needs to be respawned somehow, right? And that is something that I invite you guys to figure out on your own. I'm giving you a little bit of a hint here by doing score manager, setting it in start. If the ball can be destroyed, then all of its references can be destroyed, right? So every time it gets respawned, we need to find the score manager again. Now, there is another way that you could do this by having some sort of upper level manager, like a game manager, that detects when balls get destroyed, when balls touch score zones, and so on and so forth, right? But I leave that to you to figure out. For now, we're just going to set it in start. We want to access game objects, static method, find. This will find any game object by name. We named our game object score manager. We want to get the component on that game object. That is the score manager script. Score manager script, there we go. Close it out. And then we want to increment score by 1. And we also want to update our UI, right? So maybe on our score manager, we have some sort of public function called update score text, which we haven't written yet, but we will. So let's do that. Let's go to score manager. Let's have a public void function called update score text. We simply want to update our score text. And the way that we do this, when you're using TextMesh Pro, you'll need to do a couple things. You want to make sure that you are using TM Pro. That's the namespace for TextMesh Pro. And we want to have some sort of reference, right, to the text that we have in the top left corner of our screen. So we can set this in the usual way, serialize field, private. This particular class is called TMP. Actually, I think it's TMP text. TMP text, score text. And we want score text dot text. We'll get to why that is in a second. score text.text is equal to score plus score. The property score that we're recording and the text score, colon, space, etc. Now everything should be happy. If we go to our ball, there it is. That function updated. Okay. Cool. Let's head back to Unity. All right, we're in Unity. We have things working, hopefully. This is our game. Let's see what happens. Let's hit play. And let's hit space. Something happened. What happened? Let's debug. We have a null reference exception, an object reference not set to an instance of an object. Update score text. I forgot to assign. In Score Manager, we have this field, score text. I forgot to assign our UI element to it, so let's do that. We have our canvas score text. I'm going to drag this over. There it is. The reason, by the way, that it is in the code scoreText.text is because this particular score text is the TMP text object, which contains the field text, which is actually what we are editing in Unity in this field here. So make sure that you do that if you are using TextMesh Pro. All right, so let's save, try this again. All right, gonna hit space. Hey, score 1, score 2. So it added a double score, again, when it fell through our score zone on the way down. I think an interesting extension of this project would be to see if you can limit it so that it only adds a score on the upward swing rather than the downward. And also, maybe, another extension that I wanted to do myself during this demo, but we're running out of time, to add multiple blockers. So every time you score a point, you add another blocker to make it a little bit more difficult. That is also another reasonable extension of this. Also, maybe if the ball happens to roll off of the platform, destroy it and respawn it in the center of the platform. And make sure that all of our references are working correctly. That is also a way that you could take this, if you are interested in doing more exploration on your own. Okay, so that was a little long. I apologize for the OBS issues. Learning by doing. And I hope that you all get something from this. I'm going to stop the recording. Thank you for those of you who joined today and who are playing the home game. I hope that you all have a lovely Friday. I'm going to stick around for just a little bit after I stop recording here.